About once every century, a massive star somewhere in our galaxy runs out of fuel. This happens after millions of years of heat and pressure have fused the star's hydrogen into heavier elements like helium, carbon, and nitrogen, all the way to iron. No longer able to produce sufficient energy to maintain its structure, it collapses under its own gravitational pressure and explodes in a supernova. The star shoots most of its innards into space, seeding the galaxy with heavy elements. But what this cataclysmic eruption leaves behind might be even more remarkable. A ball of matter so dense that atomic electrons collapse from their quantum orbits into the depths of atomic nuclei. The death of that star is the birth of a neutron star, one of the densest known objects in the universe, and a laboratory for the strange physics of supercondensed matter. But what is a neutron star? Think of a compact ball inside of which protons and electrons fuse into neutrons and form a frictionless liquid called a superfluid, surrounded by a crust. This material is incredibly dense, the equivalent of the mass of a fully loaded container ship squeezed into a human hair, or the mass of Mount Everest in a space of a sugar cube. Deeper in the crust, the neutron superfluid forms different phases that physicists call nuclear pasta, as it's squeezed from lasagna to spaghetti-like shapes. The massive precursors to neutron stars often spin. When they collapse, stars that are typically millions of kilometers wide compress down to neutron stars that are only about 25 kilometers across. But the original star's angular momentum is preserved. So for the same reason that a figure skater's spin accelerates when they bring in their arms, the neutron star spins much more rapidly than its parent. The fastest neutron star on record rotates over 700 times every second, which means that a point on its surface whirls through space at more than a fifth of the speed of light. Neutron stars also have the strongest magnetic field of any known object. This magnetic concentration forms vortexes that radiate beams from the magnetic poles. Since the poles aren't always aligned with the rotational axis of the star, the beams spin like lighthouse beacons, which appear to blink when viewed from Earth. We call those pulsars. The detection of one of these tantalizing flashing signals by astrophysicist Jocelyn Bell in 1967 was in fact the way we indirectly discovered neutron stars in the first place. An aging neutron star's furious rotation slows over a period of billions of years as it radiates away its energy in the form of electromagnetic and gravity waves. But not all neutron stars disappear so quietly. For example, we've observed binary systems where a neutron star co-orbits another star. A neutron star can feed on a lighter companion, gorging on its more loosely bound atmosphere before eventually collapsing cataclysmically into a black hole. While many stars exist as binary systems, only a small percentage of those end up as neutron star binaries, where two neutron stars circle each other in a waltz doomed to end as a merger. When they finally collide, they send gravity waves through space-time like ripples from a stone thrown into a calm lake. Einstein's theory of general relativity predicted this phenomenon over 100 years ago, but it wasn't directly verified until 2017, when gravitational wave observatories LIGO and Virgo observed a neutron star collision. Other telescopes picked up a burst of gamma rays and a flash of light, and later X-rays and radio signals, all from the same impact. That became the most studied event in the history of astronomy. It yielded a treasure trove of data that's helped pin down the speed of gravity, bolster important theories in astrophysics, and provide evidence for the origin of heavy elements like gold and platinum. Neutron stars haven't given up all their secrets yet. LIGO and Virgo are being upgraded to detect more collisions. That'll help us learn what else the spectacular demise of these dense, pulsating, spinning magnets can tell us about the universe. Continue exploring the mysteries of the universe with this playlist.